Hey everybody, welcome to another episode of this math class where today we are going to talk about a very popular and interesting topic in this arena of discrete mathematics called as recurrence relations, right? So as you see on the screen, recurrence, the word itself implies that something which repeats in a sequence, right? That's called as recurrence. So let's take the whiteboard and understand what we are essentially trying to do here. So recurrence relations, when you say recurrence, it's like, say, the current term, right? Like, say, let's say t of n. This is the current term of any expression. If that depends upon, like, say, 5 times t n minus 1 plus 4 times of t n minus 2. Let's say this is an example of a recurrence relation where the current term of any expression depends on 5 times the previous term plus 4 times the term previous to the previous term. So this is an example of recurrence relation, right? 5 and 4 is just a number. This can even be 3, this can even be 2, this can even be 1 and 1, anything like that. So one of the popular ones that we know is the Fibonacci series, right? Series, isn't it? So how do you basically come up with this Fibonacci series? It's given by f of, say, n equals f means, like, say, it can be f and t. Fn equals f of n minus 1 plus f of n minus 2, right? So the current term is always the sum of the previous two terms. That's basically Fibonacci series. And here you always have to define the boundary conditions. So, like, boundary conditions is the initial terms, like f of 0 is 0 and f of 1 is 1. If you define these two, then f of 0 is 0. The first term is 0 and the zero term is going to be 0 and the first term is going to be 1. So now we have the initial conditions. Based on this, we can apply this equation now. So 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13, 13 plus 8 equals 21, 21 plus 13 equals 34, and so on and so forth, right? It continues, right? So if you specify f of 0 equals 0, f of 1 equals 1, so you can just put these values here and get the subsequent terms. Like this, the Fibonacci sequence continues, right? So that's one of the example of a recurrence relation, Fibonacci series. Now, what are we exactly trying to solve here in recurrence relations? We are trying to find out a closed loop solution. So what is a closed loop solution? So unlike this solution where you have just specifying a generic expression that the current value is a sum of the previous two values. But for any value of, like, say, n equals 17, what's going to be fn? It's going to be, okay, it's going to be f16 plus f15, right? That's f17. But then what is f15 and what is f16 and f15? That's again the question, right? So we have to keep on substituting there. So that's not something which we want to do. We want to find out a general f of n, like a function of n, where if we substitute the value of n here equal to 17, directly we need to get the value of that term. That's the expression we are trying to find out. That's called as a closed loop solution, right? Like, say, if f of n equals, like, say, n squared plus 2n plus 3, then if you substitute the value of, like, say, n over here, you directly get the value of f of n here. That's kind of a closed loop solution, is what you're trying to find out given a particular expression. That's called as solving recurrence relations. Clear? So now, before going there, we just need to understand the types of recurrence relations. Okay, so the first classification is going to be linear versus non-linear. So what are linear recurrence relations? Say f of n equals 3f n minus 1 plus 2 f n minus 2. This is a linear expression because both fn minus 1 and fn minus 2 have the power equal to 1. But then if you look at this one, say fn equals 2f n minus 1 bracket square plus 3 point blah blah plus say 3 f n minus 2. Right? So this is an example of a non-linear recurrence relation because this one, fn minus 1, is a power equal to 2. All right? Yep. So that's linear versus non-linear. Okay, this can be 2, 3. Even in that case, it's a non-linear one. The second categorization is homogeneous versus non-homogeneous. Right? So what is this thing now? Homogeneous versus, let's take an example. If we have, say, fn minus 1 equals, sorry, what am I doing? Say fn equals 2fn minus 1 plus fn minus 2 plus, say, 34n. All right. So this expression, you see it has something at the end, which is, say, a function of n. Such an expression is called as a non-homogeneous expression. Right? But if you just have a simple expression like this, without any f of n at the end, right, then it's a homogeneous expression. All right? So that's homogeneous versus non-homogeneous. And then the third thing we have to discuss is the order of the recurrence relation. So like say, for example, you have fn equals 3fn minus 1 plus 2fn minus 2 plus 10. All right. So this is a second order recurrence relation because the current term depends on the previous two terms. So that's a second order recurrence relation. But then take, for example, another one. Let's say fn equals 3fn minus 1 plus 15. So this is a first order recurrence relation because the current term depends only on the previous one term. This is a first order recurrence relation. Clear? So these are the different types of recurrence relations, right? And the different categories and the order. Now, another discussion surrounding this is how do you solve them? All right. So like there are typically four methods to solve. The first one is the brute force method. Second one is the characteristic equation method. Right. The third one is called as generating functions method. Fourth one is called as substitution or recursion trees. Right. So in the next videos, we're going to take each of these methods and see how we can solve recurrence relations. All right. So is this clear? What are recurrence relations? What are the different types of recurrence relations? And then how do you solve recurrence relations, right? This is the discussion surrounding that. So I hope this video was helpful to all of you. If you have any questions, please feel free to comment at the bottom of the video, and please do not forget to like the video and subscribe to the channel. So until then, I wish you happy studying. See you in another video with another episode, with another discussion. So until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.